For the Timber Sky Hive Challenge, we didn't just want to design any building and replace the concrete and steel with timber to make it more sustainable. Instead, we looked to see what special characteristics timber has and used that to derive the design of the building. And it allowed for a rather interesting idea. One of the special characteristics of timber is its aesthetics. It is a material that is beautiful by nature, so it doesn't need to be covered up or decorated with other materials. And also, with the advancement of our understanding of timber, we no longer need to protect it from the elements, we can treat it for long-term exposure. So this creates a unique opportunity to take the structure of the building out of the building envelope and use it as part of the facade, and turn it into a sort of an exoskeleton for the building. By separating the structure of the building from the building envelope, not only we get to use the natural beauty of timber to give the building a more natural and approachable feel, but we can also derive two additional benefits from it. First, we would no longer have the structure of the building puncturing the building envelope, creating paths for energy loss, also known as thermal bridges, which is one of the main causes of energy loss in buildings. And secondly, we would be able to build the units as prefabricated modules and then just drop them in place within the exoskeleton of the building. And since separating the structure of the building would make the units identical, it would open the way to mass production, which can further improve the quality of construction and reduce cost. So what we came up with is an arrangement where the building is made entirely out of identical units. And the rotation of the units change at every floor to use the roof of one unit as the balcony of the unit above it. For this, we had to come up with a floor plan that was, first of all, usable in two different directions, because it would be rotated on every floor to create the balconies. And secondly, could also be effectively divided into modules the size of a standard shipping container, so that the modules can be transported on site on the back of a truck. In order for this to work, the structure of the building had to be continuous, meaning that the columns on every floor had to all line up, as they do in traditional buildings. So we had to take this into account for the design of a floor plan. We had to design the floor plan and the modules that it is made of in a way that would allow the modules to rotate on every floor without interfering with the placement of the columns. So our design for the structure and the modules allows the modules to fit within the structure in different orientations without interfering with the placement of the columns. The modules rotate, but the columns are still aligned and continuous.